the links shared with you in this session. And here we go. So I hope everyone is seeing my screen. If not, you can unmute or raise your hand. Please feel free to interrupt us during this session. We want it to be interactive and we want people to participate. So I will quickly introduce the platform for people who are joining us for the first time. So DATA+WOMEN is an initiative that has been established by Tableau, which is a visualization software. This group is present in major cities and it counts thousands of members by now. Since it is sponsored by Tableau, we accept co-sponsors on an event-by-event basis. So for example, sponsors that could provide us an event location. In COVID times, that's not really possible, so we are on Zoom. For those who are familiar with other Tableau groups, like the Tableau user group, how DATA+WOMEN is different from TUG or Tableau user group is that we can talk about any data topic. We're not constrained to talk about Tableau. But since Tableau is so nice to work with, today we are going to heavily focus on Tableau. But our previous events have focused on other data topics. So I have not told you what is DATA+WOMEN. It is an initiative by Tableau, and the point is to create a community and a meetup group for women to share their experiences, for women who work in and with data in any shape or form. And the aim is to promote and celebrate the achievement of women in these areas. I have to say that DATA+WOMEN does not mean data-women. So everyone is welcome to join, and I think that we see already that there's a healthy participation of men in today's event. So thank you guys for joining us. How this event will work, as I said, the session is being recorded and it will be made available. This session is quite technical with a lot of Tableau tips and tricks, and the material that we show here, we will make it public. We will publish it to Tableau Public, so it will be public. There's no need to rush to write down the links. Our next event will be held in March, and we will focus on maps in Tableau, especially the new layer feature. Again, you will receive all the relevant links in a follow-up email. So for this evening, please, you must enjoy the talks, ask questions, and have fun. The agenda very quickly, we are covering two topics today. Today we decided to look at the previous year's Iron Viz. I will explain it in a moment. And these are three very, very nice and complex visualizations created by participants from around the world. And they have been judged by some Tableau judges, and obviously there's a winner, but I think the three are the winners. The next talk will be by Joanna, who is the co-host with me here, and she will be talking about the various ways in which you can combine data in Tableau and the good and the bad of each of these methods. And of course, we have a session for questions and networking, but as I said, please feel free to interrupt us also during the talks. So let's dive into it. I will share, for my first talk, I will share the relevant slides. Right, so I hope that the slides are being projected. So yeah, the Tableau, the 2020 Iron Viz, Tableau Iron Viz. What is Iron Viz? For those who are unfamiliar, it is a yearly competition that is again held by Tableau, so it's sponsored by Tableau. Anyone can submit a visualization on a theme that is decided by Tableau. And the top three of those visualizations submitted then go head on in a live competition. That usually happens during the Tableau conference, which takes place in the US. This time, obviously, the Tableau conference was virtual, but I can assure you that the competition was very real. I have a link to the YouTube video. Tableau has a very nicely made this available to us, so you can see how the participants have created these amazing visualizations in 20 minutes or something ridiculous like that. Obviously, they have had time to prepare before, but it is quite a video to watch if you like. The official criteria for judging these quizzes are the submission, the analysis of the data set that has been provided, the design of the submission, and the storytelling in the visualization. I have added my personal criteria, which is a guided navigation, because sometimes I find dashboards very hard to navigate, especially if you're not familiar with the topic. And also, I think one of the criteria for me is minimum or no manipulation of data or preparation of data beforehand. I think that helps with the maintenance of the data sets, of the dashboards. But these are just my criteria. At the end, I will obviously reveal who were the winners of the official winners of this competition. So yeah, let's dive right into it. These are the 3 finalists who went head on with each other last year, and they created these superb quizzes that you can, a preview of which you can see on my screen right now. There was Alex Jones, there was Christian Felix, and there was Simon Beaumont. The data set, as you can gather from the writing on their dashboards, the titles on their dashboards, was about air pollution in cities. So basically, almost all of them have looked at air pollution data from major cities of the world. And as you can imagine, the axes are the location of the city, the population, and the measure of pollution in that city. So yeah, let's dive right into it. This is going to be very technical. I'm going to share with you each dashboard, and then how I have deconstructed it and tried to learn their superb tricks. So let me share my screen again. All right. So I hope that I'm sharing my screen. So we will look at, I'm going by alphabetical order. This is not the order of the winners. So I will look at first Alex Jones's entry to the event, and this is his dashboard. I can also show you how it looks like on Tableau Public. For those of you who are unfamiliar, Tableau Public is public.tableau.com. Anyone can make a profile here, and they can either submit their own publish their own visualizations here, or look at other people's visualization and download them. I think this makes Tableau a very nice tool to work with, because you can always download and look at the work of others, which is extremely helpful. So yeah, this is Alex Jones's entry. Let me put it to full screen. Okay, did not help. So Alex Jones, what he has done in his dashboard is that he has listed, excuse me, the cities ordered by longitude and latitude. So these are the cities that he has looked at, and he has looked at a lot of measures of pollution. So you see the legend here on the left. So in this yellow circle, he represents emissions. In this gray circle, he represents population. Then he also represents energy demand of 2 different types by these 2 little lines that are hardly present in some of the cities, but very present in some others. Then he represents this with this red or orange square, the concentration of coarse particles and fine particles on the 2 axes. And the black line on top of these guys represents if they fail, so if they exceed the WHO guideline for these particles. Quite dense to read, really. For example, for Tokyo, you see that huge population, few emissions, Shanghai, huge population, huge emissions. Also, they have all exceeded the WHO guidelines for coarse particles and fine particles, and so on. New York, for example, is doing relatively well if you compare it to a city like Shanghai, in terms of the ratio of its population to the emission, to the coarse particle concentration, the orange square. As I said, I find that this is a lot of information, and if one is not familiar with environmental issues, it is very hard to interpret what these the interplay of these different not dimensions, these different measures means. But I think that still we can appreciate the just the complexity and the beautifulness of his visualization. This is not all. He has built in a lot of interactivity into his visualization. So, for example, he lets you highlight, for example, the most, so the cities with the most the highest concentration of fine particles. If you click here, he shows you that 10 are cities fall into that category, and then you have to click here again to filter those 10. I find this a little bit non-intuitive, but okay. We can also look at some other, so let's say by population, if we go, 5 are the most populated cities in this data set, and if we then click again to highlight those 5, we can see those 5 cities highlighted. I think it is nice to see them on the longitude and the latitude, but I personally find that without a map, it is hard for me to put the longitude and the latitude mentally on Earth, like where's Shanghai and where's Istanbul. But it is Alex Jones's interpretation. He also has some information. Yeah, he details where the data are taken from and so on. I think it's good practice to tell people where your data is coming from. Also, each city has its own information. I have a hard time making it come up. Yeah. So if you hover over each city, you can get details of all the measures of pollution in the city, even pointers to more. Oops, I clicked it. Pointers to more information, and some comments that I do not know where the comments come from. Either they are his interpretation or have been taken from a data set. So very, very cool, I think. I was intrigued as to how he built these little shapes, and therefore I downloaded his Viz and I delved into it and tried to see what he has done. So now you see my screen where I have downloaded his Tableau dashboard. And I went through. I think the first thing you should remark is that these guys have used background images very nicely. So this is the dashboard again in Tableau. And if you just look at the background image that has been used, it looks like this. So they're really, really taken advantage of placing correctly all the elements that are not related to Tableau visualization. Just put them on an image and put the image on the background to, I think, most likely to save time during the competition. We will do the same for the others, so you can see what they have done. But a really, really nice idea. So in this visualization, I think there's a lot of interactivity, and I don't think this is the time to go through all the actions. You probably are familiar with them, or if not, we can do another session on actions and how this interactivity is built. But I'm interested in how he built this map. So yeah, this map is really at the heart of his visualizations. And if you look closely, it is really a set of polygons in Tableau. We will just look at them in a few seconds. Each polygon represents a metric, as we have seen in the legend, and the polygons are positioned along the x and y axes depending on their longitude and latitude. So he has done a lot of data prep for to create these polygons. I mean, hats off. So the data prep looks like this. I'm just looking at one city, and you can imagine how many lines one city has. So he has had to generate for one city in order to create this viz. So for example, for Tokyo, for each city and for each metric, he creates an x and y point, well, actually a set of x and y points, which place them somewhere on this grid. And then he also introduces a variable just called path, which we will see just now, which will be used to help put the city, help fill the polygon correctly. So if I go to my next picture, yeah, if we just take the data that we saw here, the x and the y, and we just plot it on Tableau, you're already familiar with x and y, and color it with the color of the type of emission, this is what it would look like. And the genius thing is then to put the variable path on the path of polygon, and Tableau fills the gaps nicely for you. So you go from here to here by using the variable path that I showed you in the first graph. So this is basically his secret to, so this is one example, but it's basically doing the same thing for every city. So I think, first of all, there's huge data prep involved in his visualization, quite time intensive, I'm guessing, and also coming up with this encoding of different information in different polygons with different colors. Very well done. I think it's quite nice. Since we are going by alphabetical orders, let's go to the next viz, which was, so we have looked at Alex Jones, then we have Christian Felix. So his visualization looks like this. This is what he submitted. This is what he created for the competition, the air we breathe. And what he has done, he has taken a classical map with a twist. So, oops, it is reloading. Right, so he has taken a map. Basically, each city on the map is the city that he has looked at. What he has done, he has counted the cities in terms of their category, and their category is either the level of pollution in those cities is healthy, or it is moderate, or it is unhealthy. So you can see that according to the categorization that Christian has chosen to do, 55 cities have a healthy air, 44 moderate, and 60 not so healthy. And you can, it's interesting to see the geographical distribution of the city healthy air and with unhealthy air. So you can see that the cities with healthy air are mostly in the west, and with the unhealthy air are mostly developing countries. Not so surprising, I guess, but I'm not an environmental scientist, so I will not comment on how to interpret this more than this. So as you can see, the real power of his visualization is this map where you trace these lines to each city. It is very easy to put a city on the map, but then to trace these lines to the city and to color them according to what he thinks is healthy, moderate, or unhealthy air in the city is quite the nice thing about his visualization. He also lets you toggle between city and population. So this is the default view where you just see the pointer to the city's location. You can size them by population, and this even shows you another view of the same data, which is quite interesting. And you see that actually a lot of the world's population is living in places where you would qualify the air quality to be unhealthy. I think this is quite striking when you look at these numbers, when you switch just from the number of cities. Another thing Felix has done is he has gone further and done some more analysis, as in he's tried to understand if there's any relationship between the healthy, the air quality of a city or of a place and their GDP. And he realized that there was indeed a correlation. So using that correlation, he has generated scenarios. And he has generated scenarios where if you could improve the GDP of different cities by X amount, how would their air quality improve? And here there's a nice use of what we call pages in Tableau. So if I play this animation, you will see that these numbers change according to how much you have improved the GDP of that particular country. And obviously you will see that these guys will not change much, but the guys that are yellow or white in this graph will change. So I will just play the animation. So you see a 1% change, not so much. 10% change, you see that the proportion of people living in unhealthy places changes, and then with a 20% change, you see that the proportion of people living in unhealthy places changes a lot. So I think it's quite a nice analysis, or a nice attempt at the analysis. He also provides something that is quite nice, which is go to sources. So it's a link to another dashboard, which is right here in the same Tableau workbook. And here he basically lists all the data gathering and the methodology that he has used in order to, for example, classify a city as having a good air quality, moderate, and unhealthy, and so on. So we can go back to the previous visualization. So yeah, let's dive into Christian Felix's visualization on my computer, and here it is. I downloaded it again, and I tried to look how he has created his beautiful visualization. So as we did with Alex Jones, I will show you what his background picture looks like. And again, he has also used he has also created a lot of the text and the boxes that he needs to create already in his background image in order to save time during the competition, which is quite nice. Fair enough. Let's go to the map. So in this dashboard, all the heavy lifting is basically done by this guy. So how do you create this visualization basically? And if you look at what he has done, he has also done a lot of data preparation. So for each city, he has generated 100 data points, each of which is a longitude and a latitude. And these data points are used to trace the city to its actual location on the Earth. So they all start here, and then they are traced to its actual location on Earth. And the last point has a flag, which is called end. Well, you can do it however you want, but he has chosen to call it end. And basically he draws a circle whenever the point is ends. It's the last point. Here you can see, oops, let's go through the example properly. So here you can see that for Australia, for example, for one city in Australia, Adelaide, you see the set of points. So you see that he has 100 points. And then what he has done is he has generated this variable end, which will be used to create the circle at this location. And then actually, in order to simulate the change in the GDP, as we saw before, he has then repeated the same set of data 4 times in order to simulate no change, 10% change, 20% change, and 30% change in the city's GDP. For Adelaide, it makes no difference. So you see that the points are the same, but if it were a city that were to move with a different GDP, then we would see the line move, which would mean that the coordinates will be different. So yeah, it's quite a lot of data prep, and it's a very nice idea. I think that it is quite obvious to navigate. This is right in front of you when you come to the visualization, so you can have the reflex to kind of toggle this, and once you toggle this, you are taken aback by the distribution of the population. And then I think the idea is that, having seen that, someone would like to try to read this text and understand why this is. But I do think that it is not clear after navigating from here. It is not clear what I should read and how I should interpret the difference between the two graphs. But this is again my opinion. So yeah, very nice visualization and a very nice trick of drawing these lines. And we are going to go to the last entry of this Iron Viz, which is by Simon Beaumont. So this is what his entry looks like on Tableau Public. Right, so his visualization is basically a bar graph if you want, but it is quite a tricky bar graph, as we will see later. What he's trying to show is roughly what Felix tried to show in a different way, which is the percent of population of the world that is living in places that are under or over the WHO safety limit of pollution by PM 2.5 particles. So as you might have noticed that Christian and Simon have chosen to look at only one kind of pollutant, while Alex has basically tried to represent all the types of pollutants in one graph. So again, you can interpret it in any ways. I prefer the approach of showing one type of pollutant and trying to explain it rather than all at once, because again, being a non-expert, it becomes difficult to interpret. Anyway, so Simon. Okay, so the visualization again is quite catchy. I think it takes a little bit of time when you come here to try to understand where you should start, because there's a lot of text. And then there's one graph and your eye gets attracted to this graph, but then there's another one as well. So you really don't know, and they're not really related. But yeah, if you read a little bit, you kind of understand what he's doing. So first of all, he has a toggle button here where he can explain to you what kind of pollution he's looking at. So he's looking at exactly these particles, PM 2.5, and he has explained their hazards and how they come to be. So I find it quite nice. Not intuitive to click on this question mark, but maybe it's intuitive for some people. So then let's go from the point of view of a person who reads from left to right. So I would read it like this. So I would try to look at this side of the dashboard first. And so it is very clear that what he's looking at is how many people live in places that exceed the WHO's recommended values for these pollutant particles. So yeah, 4.7% kind of lives in a safe a level of pollution, and the 95% live in places that exceed this level. And then he kind of puts the gradation into this 95. Okay, but how many are living in places where it's the pollution exceeds 1 time the limit, 2 times the limit, 3 times the limit, etc. So this is the second bar, and then he goes ahead and actually divides it by city, so you can actually look at each city. And what you can see here is on the y-axis is the pollution. So this is the safe limit by WHO, sorry, the black line. And so the length of the bars represents the how much it exceeds, by how much it exceeds the safe limit. And actually the width of the bar represents the population. So you can see that big cities are here, but also here, here. And then probably a logical conclusion is to read this. Big does not necessarily mean bad. And then he tries to explain the story behind a few cities. I do not know why he has selected to use only these 3 cities. So sorry, countries, so Norway, Bolivia, and China. But there you go. So what he has tried to do is understand why, for example, Norway is here. Somewhere here, if I can find it. So Oslo is here, for example. They are well below, I think, yeah, a little bit over the limit by WHO, but okay. He believes that this is the result of environmental policies in Norway. They have increased the price. So if you look at, if you compare the gasoline price, it's quite expensive in Norway, and people don't travel that much. So kind of makes sense. Then he goes to Bolivia, which is this huge, sorry, if I can find it. Okay, La Paz, for example. He tries to explain why they are not hugely populated, but they are still exceeding a lot the WHO safety limit. So again, he plots where Bolivia stands in terms of gasoline price. And yeah, he also explains that it probably is the geography of the place that would explain spending so much energy to travel. And then he looks at China, because this is the biggest block here and it exceeds the WHO's limit by 8 times. And he claims that no Chinese cities within the WHO dataset achieve the air quality that would be called safe by the WHO. So unfortunate, but probably a result of China's policies. They don't comment more, and neither am I qualified to comment more. One thing that does not come across is actually that these are buttons. These have some information coming up, but these are also buttons. So you can toggle, for example, here we have toggled for size, for population size. And here we toggle again. Oops, what have I done? I've broken it. Yeah. So it is not immediately clear that one should click here or even bring their mouse here, but I find that it is a very nice information that he provides here. For example, if you click on Norway, he has this little whiz come up here to tell you where Norway is on the graph. And the same thing would happen here with La Paz. And then China, of course. Well, Beijing is here. So this is quite nice. I like this idea, but I think that it is not intuitive. I would not have gone and clicked on it. Of course, I have seen the video and Simon explained that you have to click here. So I know. So let's dive into his visualization. Like I really like this one. So here is the copy of Simon's visualization on my laptop. Let's go to the background. Again, he has used the background image to his advantage. You can see he has placed a lot of text, a lot of stuff already on his background image. So even the legend he has already put as a background image. So basically he just had to put even this text. So you see even this text is part of the background. And he has just put the correct bars at the correct place. As we can see, these are quite easy to make, but this guy, this bar chart, is really a stroke of genius, and I will show you why. So yeah, the most striking thing in his entry is this two-dimensional bar chart. The issue with this bar chart, if you are a Tableau freak, is that he has plotted 2 measures on 2 axes, and there's no dimension. And the way he has achieved this is very interesting. So first of all, he does not seem to have a lot of data prep going on. So he has not repeated lines for a city, for example. His dataset is much simpler than the previous 2 that we have discussed. So for each city, he has basically in his dataset the the concentration of PM 2.5 particles in the air, the population, and then a threshold exceed int, which is basically by how many times does this city exceed the threshold. So the threshold given by WHO is 10. So this city exceeds by 1 time the threshold. This city is actually under the threshold, and so on and so forth. So it's quite a simple data set, relatively simple data set. So yeah, the chart creation is quite nicely done. You would think that what you could do is put the population and the pollution level on X and Y axes and invert the axis, because that's exactly what's going on here. This axis is population, so the width of the bar is population, and the length of the bar is the concentration of these particles. And this axis is inversed actually. So this is going from 0 to 90 instead of going from here 0 to 90. So if you just do that, simply put population and this pollution measure on the 2 axes, you will achieve this. You can get the correct colors, fine. But yeah, since there's no dimension here, there's no way to kind of order these graphs, order these bars correctly and give them the length, the width that you would like to give them. So the genius trick is that you need to, I will show you here, that we need to create space on the x-axis, which is the axis of population, for each city. And that he does by converting it into a accumulated sum. So what he does is he changes this simple sum to accumulated sum. And then your viz looks like this. It starts to get ordered, but there's one more trick left, which is to fix the size of the bar to the population. And once you do that, you achieve his visualization. So I think it is a very, very genius trick. It is simple, it is elegant. Like, who knew that you could do this with a bar chart, right? It's tried and tested, and people think that they have mastered the bar chart. So overall, I really like this trick. I like the simplicity in the data set, not a lot of data prep. The navigation is a little bit complex, but yeah, if you take a minute to read, you kind of follow his logic. So let me go back to my slides. So we have seen all these phases. I hope that I was able to explain how they have achieved this. Anyway, I will put this on Tableau Public so you can download. And the winner. I think I have given you an impression of what I liked and did not like, but the official winner was Christian Felix. The second place went to Simon, and the third place went to Alex. I personally think that Simon's was really impressive because it is very, very innovative use of bar charts, and bar charts are like banal, and he has made a very, very good use of it, and also with a very small amount of data manipulation, which I really like. Christian's viz had an interesting analytical component. Remember that Christian created this graph to show you how the air quality would evolve if you improve the GDP. So it has an analytical component, which is quite nice, but he has a lot of data prep. And Alex's viz very, very rich in information, but I think, personally speaking, I find it hard to interpret since it is so rich in information, and also involves an insane amount of data prep to create all the longitudes and latitudes, and then create all the elements to create the polygons. But that's my opinion, and this is the official order of winners. I really thank all the participants and Tableau for making all this stuff public, because it's extremely interesting and instructive for people like me to be able to look at their vizes. And thank you for paying attention to this talk. I hope that it was useful. I'm gonna hand over to Joanna, and we can take questions later if there are any.
All right, thank you, Fatima. Can you hear me okay?
I can, yeah.
Yeah, that was very, very interesting. I love that deconstruction, and I have to agree with you. The more you get, I think, exposed to Tableau, the more I appreciate not increasing complexity and amount of data if you don't have to. And bar charts are great, as I think I'll show next as well. So yeah, I have to agree with you. I enjoyed the second place Viz a lot for its simplicity. Yeah.
Yeah. Good. Thank
All
you,
right.
Joanna.
So I think I can share my screen now. Can you let me know if that works and if you can see it and if you can hear me okay?
I can.
Okay, fantastic. So we move on to the second part of today's event, where we're going to be discussing, as Fatima already mentioned, basically the different ways you can combine data in Tableau and what are the pros, the cons, and the limitations of each, and some tips and tricks to overcome limitations, which I think is probably one of my favorite things of Tableau, is when you can't figure out how to do something, there's usually a weird tip or trick that you can use to get around it. All right, so let's start. So as I said, we're going to be discussing first combining data in Tableau, because more often than not, you'll need to combine data from different sources in your dashboards and your analysis. So here's an example. I have a data source that I'll call orders. And it's just a table that has the list of the orders that were placed with my fictitious store. I don't actually have a store. This is actually a subset of the well-known Superstore Tableau dataset. So what I'll point out is that each row in this table is an order, and you have information, for example, the order number, the date the order was placed, the amount of sales of that order, the profit, the items that were shipped, how they were shipped, the category, and information like this. So each row is an order that was placed with the store. And then on a separate data source, on a separate table, I have the targets. So basically the sales quota that my store is supposed to meet in each of these categories. So you can see basically the granularity, the level of detail in these two tables is different. Here we're looking at one order per row, and here we're looking at one category per row. And this will be, the reason I'm pointing this out will become clear later. So our goal is we have these two separate tables, these two separate sources, and we want to check if we're meeting our targets in terms of sales. And sales needs to come from here, and our targets come from here. So how do we do this in Tableau? First of all, let's just have a look. Oh, by the way, I didn't say this, but this is going to be quite interactive, but you should feel free to interrupt. And as Fatima already mentioned, we're going to make this available later. So you also shouldn't feel like you have to do it at the same time or rush to take notes or something. So you'll have the workbooks available. All right, so just to start, let's inspect a bit more. I already created the data sources in advance. So here I just connected to the orders table that I just showed you a preview of. This is a simple, just single table with the orders. And as I mentioned, we're going to be looking into using this source to look at the sales per category. So something like this. There we go. And the nice bar chart, nothing wrong with the bar chart. Big fan of a bar chart. So there we go. So we have, for example, 4.4 million in sales in the category telephones and communication, 4.3 for office machines, and down at the bottom, rubber bands, 30,000, almost 31,000 in sales. All right, so let's now have a look at our other data source. That's the targets. Let me just show you. I just connected directly to the targets table, which, as we saw, has just the category and the sales quota we're supposed to meet. So in this source, we're interested in the quota. Let's plot that for each category. So here I'm just changing the view a little bit and sorting it. And yeah, so for example, we're supposed to sell 4.1 million in chairs and chair mats. And here, for what's coming up next, I'm going to ask you to focus on the quota for appliances. So our quota for appliances is 1.1 million. All right, so let's try to combine these two so we can check if we're meeting our quotas, our targets in sales. There's basically 3 ways you can combine data in Tableau, and we're going to go through all of them. They are joins, relationships, and blends. So let's start with joins. There we go. So again, I've already created the source. Let's have a look at it. So what I did was basically I brought in my orders table, my targets table, and I joined them. So join is quite a fixed merging of the 2 tables. What happens is I chose the left join, which means that all fields are kept on this table regardless of whether or not they have a match in this table. But basically the idea behind a join is you have 2 tables, you join them over a common field. In this case, it's category, and the outcome is a single table, a single merged table, join table. All right, so let's go back, and we have a single table. We've brought our information together into a single table. So let's try to see what happens when we try to compare our sales for each category. There we go. Let's make this look a bit more like it did before. And now I'm going to make it full entire view so that you can see this better. And I'm going to bring in the quota because now I have the quota in a single. I have everything I need in my single source. So I'm bringing in the quota. Right now they're shown side by side, but something already looks quite weird. Have a look at the axis here. It goes up to 7 billion. And if you remember, our quota for appliances was 1.1 million, but now I see basically almost 1 billion. So what's happening here? Clearly something doesn't look right. So let's have a look into what happens when we actually join this and when we merge these 2 tables together. If you remember, our orders table, for each row, we had an order. So I'm going to bring in the row number and the order number. So each row is an order. I'm actually going to filter this to appliances because that's an easy one to memorize the quota for that we remember. Anyway, so let's bring in the sales into the Viz. So what we see here for each row, we have the order number and the sales amount of this order. And now let's bring in the quota. There we go. So now let's maybe go like this. So what you can see is because all of the sales belong to the appliances category, and the quota for appliances is 1.1 million, the quota associated to each sale is 1.1 million. So when we do our Viz and we're not looking at each individual order, Tableau will aggregate your measures. So this is what's happening. It will aggregate by default by summing them. So to get the sales of appliances, you sum all the sales of every appliance, but then it's doing the same thing for quota. So what you're getting is a sum of 1.1 million for every appliance that was sold, which is clearly wrong. So how do we get around this? There's a couple ways to get around this. One way, so we're back to the Viz that clearly looks wrong. One way is you just change the aggregation. As we discussed, by default, Tableau will sum your measures, but this is not what we want. We don't want to sum it. It's going to be 1.1 million for every appliance. So instead of doing 1.1 plus 1.1, I can just change it to an average. And then I recover my 1.1 million quota. Or I can change it to max or min. I think these are actually preferable in terms of performance compared to the average. But yeah, because min it will be 1.1 for every row. Any of these aggregations that is not a sum will work. So yeah, so just like that, we can now make this, for example, let's make this a dual axis. Let's see, let's make this look a bit nicer for the comparison. We can make this a bar and maybe make this, there we go. Let's remove this. I'm gonna make this I'm going to just make this black. So we just have bars at the end that show our target. Let me make this a bit bigger. Let's synchronize the axes. Often forget. And then once we do that, we can hide it. Dual axis. There we go. Show header. All right. So we have a nice bar chart that makes sense, that actually shows for each of the categories our sales in the bar, and the sort of bullet at the end gives us our quota and if we're meeting the quota or not. Now, let me just show you something. Let me drag the department into the viz. As you can see, each category belongs to a department. And what happens now, if I want to check if the sales within a department instead of a category are meeting the quota? Let's see what happens. It may look like this is correct, but because we changed disaggregation, the quota that is shown here is the minimum quota for this department. So for example, let's have a look. For furniture, we have office furniture furnishings with a minimum quota of 1.3 million. And this is what is shown here. So this trick of changing the aggregation works if you're working at the right level of detail. Once you change that, it's not really right anymore. So what is the right way to do this? Because I think when you're building your viz, you want to give the possibility for people to interact and be able to get the right answer, hopefully always. Okay, so how do you get around this? To get around this, you basically need to create a level of detail calculation. So I already created that. Let me show you. Sorry, quota per category. Let's have a look. So basically what this is saying is telling Tableau it's fixed on categories. So it basically tells Tableau for each category, return the minimum quota. Here again, I could have used minimum, max, average. It's the same for every category, right? You get that duplication on every row. So this fixed level of detail calculation, let's use it now instead of directly the quota. And this can now be summed, which is what we want. Have a look at department. So what I'm telling is Tableau for each category, just return a single value of quota, but then sum, which is what we want to then get for department. The quota for the furniture department is the sum of the quota of the categories within the department. And bam, with this, we get the right answers. We can make this a bit nicer now. We can, for example, let's see, create a calculation that checks if the sum of sales is above the sum of quota per category. So the fixed level of detail calculation that we just created, we can drag that onto color, and then, well, we can remove this again. And now it's very clear. Let me actually just put that over here. There we go. And now it's very clear which categories are meeting the quota and which categories are not, and also which categories we don't have a quota for. So here we see there's no little bar. That's because our targets data does not have a target set for the storage and organization category. All right. So with that, we're going to move on to another way to combine data in Tableau, which are relationships. This was actually introduced, well, I realize now a year ago, which feels very recent because time is weird now. But yes, I think it was basically a year ago that relationships were introduced, and Tableau introduced basically a whole new data model. Let me show you. So as before, I already created the data source. And this time so I brought in the orders table and I brought in the targets table. And instead of joining them together, I added this noodle between them. This line represents, which they call the noodle, represents a relationship, again, over a common field, in this case, category. But this noodle is something a lot more flexible than a join. Basically, as you can see, I don't have a single table. I can only look at each table independently. Tableau is not merging these tables together into a single thing yet. It's just saying there's a relationship between these two things, and I'll decide later on how exactly to combine it. And the way Tableau decides is, and this is what's really nice about relationships, is that Tableau will decide how to combine based on the viz that you want to build. So let's build our viz. Just as we've done before. You've seen this now a few times. Sales per category, let's flip. And now let's add the quota. And already I can see that it's not like a join. I'm not getting the weirdly huge numbers that are getting duplicated. And the reason for this is that with relationships are really very dynamic. Each table keeps its native granularity, its native level of detail. And so Tableau, based on what you're showing, will decide how to aggregate the data and how to show it and how to do the join. Basically, ultimately, Tableau is still doing a join, but it's just a smarter join. Okay, let's dual access this like before. Let's make it nice. There we go. I want to make this look like before because there's something interesting that happened with relationships that we didn't have before. So again, I can have a calculation, and here my calculation, I don't need to use level of detail calculations. Tableau knows how to aggregate the data in the two tables that are related to each other. So here I'm just comparing some sales to some quota, and that's it. And I'm breaking that into, let's bring it into the bar color, and there. So again, let me make sure these are synced because I often forget as it's becoming clear. So here's what I want to point out. You can see here at the bottom something that we hadn't seen before. So there's a null category that doesn't have a bar, so it doesn't have any sales, but it has a target. And we can try to see what this is by basically getting the category from the targets table and not from the orders table, which is what I've been showing. Let's have a look. So we have the core. So the nice thing with relationships, as opposed to joins, basically with joins, you need to decide in advance how you're going to combine your data, and then you're stuck with that. You chose a left join, which means that there was no decor and sales, and that's gone from your merge table. With relationships, you don't need to decide in advance. And so this actually allowed us to get another insight. I don't care about categories that I don't have sales for, and I can just simply exclude this. And here I'm basically emulating the behavior of a left join. But I didn't have to decide anything in advance. Everything is built dynamically and flexibly as you're doing your visualization, which I think is quite nice. And also, for example, I can just come up here and exclude the nulls. And basically what I have is what I would get with an inner join, except I didn't have to do any level of detail calculations. So things come nicely straight out of the box, which is quite nice. All right, and now let's go to the last option that you have when you combine data in Tableau, which are blends. There we go. So blends are kind of a weird way of combining data in Tableau. Tableau is not really merging the data like we saw with joins or even with relationships. Basically, the data is actually kept very separate, and Tableau will query at one source and query another source separately and independently. It will aggregate and then will show it together in the viz. But the tables are actually kept quite separate. So I'm going to define basically with the blend, you also need to define a primary table and a secondary, a primary data source and the secondary data source. Okay, so let's try to build our viz by blending the order source with the target source. So you've seen this now a few times. I'm going to bring sales into the view category. Okay, and now I'm going to bring and now I need to go to targets, because that's where my quota comes from. Notice Tableau links the two. It gives me an orange bar here indicating that this is a secondary data source. There's a field in common, which is category, and I'll just see what happens when I bring in the quota. And already you can see that these numbers look right. We have, where are appliances, 1.1 million for appliances. So basically with blends, you get a behavior similar to relationships. And the reason for this is that Tableau is querying things separately, and basically it aggregates things individually and then just shows it together. So you don't get that duplication that you get when you're doing a join. All right, so sorry, I skipped one. So to summarize, 3 ways of combining data in Tableau. Joins, this is a sort of rigid merging of data into a single table. You need to decide on the join type in advance. As we saw, it can cause lost or duplicated data if you're working with tables at different level of detail. It may require the use of level of detail calculations. Nothing wrong with that, but as the complexity of the data sources increases, it can sometimes be tricky to figure out which level of detail calculation you want to use. And a big disadvantage of joins is if you're working with published Tableau data sources and on Tableau server, you cannot join 2 sources. So say my orders table and my targets table were published as 2 separate sources, I could not join them together. For relationships, very flexible and dynamic combination of the data. Each table keeps its native granularity. So this means you don't have any loss of data or any duplication. Tableau will decide on the correct aggregation and on the joins when you're building the viz. So they're very efficient. It's a very efficient way of combining the data and of querying the data. No need for level of detail calculations, but similar to joins, it's not available for published sources. And finally, we had a look at blends, which requires you to choose a primary and secondary data source. The data is not really combined, it's just shown together. Tableau queries the data and aggregates the data in each source separately and then just shows you the result together. And this has the consequence that blending comes with a few limitations, which we're going to discuss next. The performance can degrade very quickly with large data sets because the combination is happening at the visual level. But the nice thing with blends, well, I don't know if it's nice, it's basically the only option you have if you're working with published data sources. The only thing, if my orders and my targets are published sources in Tableau server, the only way I could produce the viz that we've been looking at is by using blending. All right, so let's look at some of the blending limitations. Blending limitation number 1, you cannot count across blended data. So what does this mean exactly? Let's have a look at our orders. Now I'm just going to look at the categories. Here's a list of my categories. I can turn this dimension into a measure where I just count the number of categories. 17. Okay, let's move this here. So my data set has 17 different categories. I can now, for example, add a filter and just show furniture. So my data set has 4 categories in the furniture department. So here we're counting the number of categories. Let's have a look now at something else. So let's again have a list of the categories. And remember, we had a calculation that checked if the sales were above quota. So we checked the sum of sales against the quota coming from the target source, so from the secondary data source. Let's bring this in. You see this little source turned orange because now we're getting information from our secondary data source. We weren't before. And we're able to categorize our categories depending on whether or not they meet the sales quota. So here you have all the categories that meet the quota. Here below the quota, here are categories that do not have a quota. Let me now change this to count distinct. And we get an error. And we get this all turned into true. We get a count of 17, which is clearly wrong. So this is what I mean. Basically, we cannot count. We can show the categories because Tableau is blending across category, but we cannot count it because it needs the secondary data to know whether or not a category is above or below quota. So this is what I meant by you cannot count across data sources. The result is very clearly wrong. Okay, so how can you get around this? We're going to show you a trick to get around this, just in case you need to count across blended sources. It will probably happen more often than you think. So the trick that we're going to show you uses sets. So sets in Tableau are a subset of the data that you define under a certain condition. And the way the sets work is the data is either inside or outside of the set. And you can use set actions to change who's in and who's out of the set. But the idea is either you're in or you're out of the set. All right, and as I mentioned, we're going to show you how you can use sets to get around this counting issue. Okay, so let's have now a look at something different than sales. Let's still look at categories, but let's look at profit ratio. Here's the profit. Let's do it at bar. Love bar charts, as you can see. Okay, so this is basically very similar to what we've been looking at, but we're showing profit ratio instead of sales. And now let's create a set of categories. So I go into category, create set. There's several ways for you to create a set. You can either select manually which categories you want in and out of the set, or you can use a condition, which is what we're going to do. I already created a set in advance, so I'm just going to edit it. So I'm going to create a set for categories with high profit ratio. And I'm going to just use the field profit ratio, and I'm going to require that it is higher than 50%. And there I created my set. So let's drag this on here and see what it is. So there you go. This is what I meant. You're either in or you're out of the set. So these categories here, which have profit ratios above 50%, are in the set. And these ones down here with profit ratios below 50% are out of the set. Nice things with sets, you can drag them onto the filters, keep only stuff that is inside the set. And now we only see categories that are in the set. Let me remove this, turn this again into a measure. And just like that, we can move this to here. We can make it like a big number that we can use in a dashboard, and you'll see why I'm doing this later. Let's put this in the middle. There we go. And just like that, we counted the number of categories inside the set high profit ratio. So there's 10 categories with profit ratio above 50%. Okay, so maybe we can try to do something similar. I went back to the viz that we produced with the blended data source. So maybe we could just try to do something similar for the quota and just make a set that checks if the category is or not above quota. So I already made this in advance. Let's try to do it. Categories above quota. Let's try to do it by condition. But I don't have my calculation above quota here. So maybe we can do it by formula. Sales above quota. But I get an error. The field is invalid. And again, the reason the field is invalid is that Tableau needs to go look in the secondary data source to get this information. So I can't use it. But for the purposes of this, let's just create an empty set. Because remember, I mentioned you can change the members of a set with set actions. So let's just create an empty set to start with. And there you go. The set is empty. All of the categories are out of the set. But now let's create an action, add an action, change set values. So add category to right now empty set. So basically what I'm saying here is every time I select, so I have to click on the viz, I'm going to assign values to my categories above quota set. And I'm going to choose to remove the values when I unclick. And let's see what happens with this action. So have a look. I'm going to click telephones and communications. And just like that, I change the membership to in. I click and it's out again. I click tables, and the tables are in the set. I click and they're out. Let me now add the calculation sales above quota, which I can add to the viz because I'm showing the category, and have a look. I click true, and my categories above quota are now in the set. So this is giving us a hint. If I can create some sort of clicking thing, I can maybe tell the set how many categories are inside, and then I can count. So this is what we're gonna do. Let me, first of all, I'm gonna remove it again. We created our set, categories above quota. I'm gonna filter on it. I'm gonna show the categories. I don't see anything because, of course, the set is empty. There's nothing inside the set. But I'm gonna change this to, well, before I filter, let me try to do this. Let's first of all change this to account, which is what we're interested on. Again, let's make it a big number. You'll see why later. There we go. Okay. Let's center and let's make it entire view. There we go. So we know we have 17 categories. And now let's add our categories above quota set, which again is empty for now, to filters. Number goes away. There's no categories above quota yet. And now let's try to create basically something that we can click. So this is something very similar to what I showed in the other viz. I'm just going to bring sales above. Well, I need to bring categories to the view as well. Let me bring categories. So there we go. We have the list of categories. The categories here, the ones that we're interested in. I'm going to actually add filter to the ones that I'm interested in. And this will be clear, but I'm basically just creating a fake button. Click me to update. Update. There we go. Okay. I'm going to bring this here, and I'm just going to hide the categories there. But this is just something that is going to let me click and give me access to the categories here. And now let's try to put all of this together. So I built a little simple mock dashboard. Here you have the viz that we've now produced 20 times using blended data. This, if you remember, we counted categories with high profit ratio. I already added this as a big number so that people looking at it know immediately how many categories have high profit ratio. And we want to add here the number of categories that have sales above quota. So I'm going to replace the, let me see, a lot of sheets, but hopefully I'll find it. I'm going to replace the X with the sheet that we created. Let's remove it. Let's hide the title. Remember, this is empty because our set is empty. And I'm going to add the button that we also made. There we go. Let's maybe move it there. There we go. Let's hide the title. I know this doesn't look like a button, but we can make it look like a button. Like that. There we go. So now it's just text. And remember, we need to change the membership of the set via an action. So let's create an action that changes the set values. The action will run when we click on our button, click, and it will add values to the set. And now I'm just going to keep the values and categories above quota. There we go. And if I click 5, we have 5 categories with sales above quota. And we can see that this is correct. These are the number of blue bars, 1, 2, 3, 4, and 5. Okay, so that covers the counting and how to overcome the counting limitation with blends. And this brings me to my last bit of demo, where another of the limitations with blending is that your secondary data source is always aggregated. And if you happen to want to drill down, you'll see that you can't. I'll just go straight ahead and show you what I mean by this. For this part, we're going to look into a different data set called sales reps. So this data set just basically has a list of states in the US and the sales representatives There we go, sorry. And the sales representatives in each of the states. What I'll point out here is that most of the states have one sales representative, but some of them have two. For example, DC, Florida, Massachusetts, and for example, New York has 3 sales reps. Okay, so let's say I want to look at the sales. Let's go back to our orders. And this time, instead of looking at sales per category, let's have, well, first of all, we're clearly interested in the US. So let's filter already to the United States. There we go. And let's look at our state, at our sales per state. So I'm going to bring in the US map, and I'm going to drag sales to color. So there we go. Dark blue means a lot of sales. Well done, California, Washington, New York. And now let's say I'm looking at this and I want my tooltip to show me the sales rep so that I know which ones are responsible for each of these numbers that I'm looking at. Let's say I'm in Tableau server, I can only blend. So there we go. I'm going to look into the sales rep source. Tableau identified the common field between the primary and secondary source, which is state. The 2 sources are linked. So I can just bring sales rep to tooltip. Okay, so Stephanie doing a good job in California. And then in Washington, the sales rep is asterisk. I don't know. New York, asterisk. Texas, asterisk. So basically, this is what I mean. You can't drill down into the secondary data source. If you remember, these are the states that had, New York had 3, Texas has 2, Washington has 2. So basically, you can't get down to the level below state. So how do you get around this? We're going to show you how to drill down into a secondary data source using parameters. So parameters are basically variables in Tableau workbooks. They can be anything you want. They can be a string, a number, a date, and similar to sets, well, you can decide what the parameter is, but then you can also add parameter actions to change what value you assign to the parameter. And again, I think this is going to become clear. So let's go back to our map. Sorry, the blue is a little bit different, but this is the same map that we were looking at before. We're looking at the stars. Let me create a parameter. Create a parameter. I've actually created one already, so I'll just show you what I did. Oh, sorry, I showed it, which is good. Let's edit. Sorry about that. Okay, so I created a parameter called state parameter. The state name is a string, obviously, so the data type is string. The current value doesn't really matter because we're going to be changing this with actions. But I made it a list, and I told Tableau to pick up the possible list of values from the state field. So that's how I built my parameter. And just before, by mistake, but it's good that I did it, I showed the parameter. So you can see right here what the parameter is. Right now it's Alabama, but you can change it to any state that is in the source, not just states that are here, because that's what I told Tableau. All right, so now let's interact with this parameter. Right now, the parameter is not being used anywhere, but let's add an action, a parameter action that changes this parameter. So change state. I'm going to run this on hover instead of selecting. So this means that I can just hover over the map and I'll be able to change the value of the parameter. And this acts on the state parameter and on the state field. And let's see what happens now with this action. Have a look at what happens here as I hover over the map. Now the parameter is New York because I'm hovering over New York. If I hover over Illinois, the parameter will become Illinois. If I hover over Colorado, I will see Colorado in the parameter. Okay. So now, the nice thing about parameters is that they belong to the workbook. They don't belong to a particular data source. So now I can go to my sales reps, and my parameter is still here. Let's show it. it's on Iowa because that's the last thing I hovered over in the previous worksheet. And let's just list our sales reps, list the state. Let's do it the other way around. And now let's create a calculation that checks state matches parameter. And I'm checking if the state equals my state parameter. There we go. I had done this before, state is selected state, but you'll see it's the same. Let me drag this here. And you can see that it's false everywhere except for Iowa, because that's what we selected as a parameter. We can go and change the parameter there that is selected to DC, and then everything will be false except for the ones in DC. Here I changed the parameter by hand, but remember, we can change the parameter using an action. And also notice that here, this is not a secondary data source. I'm just using the sales rep as the primary data source. Okay, so let's hide these things. Let's just keep the sales reps names, and hopefully that will become clear why next. And let's try to put everything together. So we have the map that we were looking at before with our parameter action set. So I actually may need to, let me just go back here. Yeah, so one thing I didn't do is I need to add this as a filter, sorry. Let me add this here. There we go. So right now I'm only showing the sales rep of the selected parameter. So yes, so now let's go back here. And what I'll add in the tooltip is the sheet that I just created. So that's sheet 27. There we go. Let's make this a bit wider so that it all fits. Okay. And there we go. So this is, as you can see, this is the first name of sales rep that shows up is the one from the blended data source. But now I have the table that I just created in the previous sheet that is filtered because my parameter is filtering it, and I'm setting the value of my parameter by hovering over my map. So for California, I see Stephanie, but for example, for Washington, before I had a star, but now I'm able to see the two individual sales reps. So yeah, that brings me to the end. I hope you've enjoyed this. We try to go through the different ways you can combine data in Tableau and the pros and cons and the limitations of each one. And hopefully we showed you how you can work around, and I find that this is generally true in Tableau. You can always find a workaround the limitations. Us at Arguzo, we maintain a blog where we have a lot of these tips and tricks, and we write about that. So if you're interested in these topics and you want to dive deeper into what we discussed here today, I recommend you have a look at our blog. And yeah, thank you for your attention. And I guess I hand over to you, Fatima.
Oh, thanks a lot, Jana. It was really a lot of information. I really like the sets, honestly. I think this is one of the best things they have introduced last year. Was it last year? The set action?
Yes, it was last year. I'm a big fan too. When they introduced it, I found myself just using it everywhere and forgetting that sometimes you could just use filters, for example.
Yeah, I love them. Thanks a lot. Thank you for everyone who is attending. Do we have any questions or comments for now before we close? I see that it's 6:30 and it's a bit late for some people, but if you have any, just raise your hand or unmute yourself. I think you can do that. I don't think anyone wants to speak.
No, everyone is shy today.
Yeah.
Okay.
Well, Shall we close then? If no one is in the
so.
network. Thanks a lot again, guys, for attending and attending this very technical session until 6:30. We will be sending you a follow-up email with all this information and links to our Tableau dashboards, so you can take a look. Thanks again, and see you next time on the 10th of March. Bye-bye.
Thank you. Bye.
Thanks, everyone.